Today, lesson number 28, we're going to be solving and graphing two-step inequalities. We've spent the last two lessons dealing with one-step inequalities. And yesterday, we had to make sure that we paid attention to whether we multiplied or divided by a negative number somewhere within the solving process. Because when we do that, we need to make sure that we flip the inequality symbol. So that's the content objective. Language objective for today is we'll be working on verbally stating what the solution represents, and I've been hinting at that, but today we're actually going to do that. All right, a little background knowledge. When you are solving a two-step equation, you always do the adding or subtracting part first, if there is that within the problem. And we're trying to make 0, which is the additive inverse property. And then after that, we do the multiplying or dividing part second. And we're trying to make 1 right there, which is the multiplicative inverse property. Well, you know what? Whenever you solve an inequality that's two steps, you do exactly the same sort of thing. In the equation, we've got one solution, x equals 4. With this inequality, you're still going to add 2 to both sides. You always deal with the adding or subtracting part first. Then you deal with the multiplying or dividing. By the way, in this one, am I going to have to reverse the inequality symbol? No, because I'm dividing by a positive number. So that makes the solution x is greater than 4. In the equation on the left, there's only one number that will make a true statement within the inequality, and that's 4. But for this, there are lots of numbers that will make a true statement, and that's why we graph. So if we graph this thing, is that an open or a closed circle?
Open.
Will the arrow be going to the left or to the right?
To the right.
To the right. All numbers that are greater than 4 are over there. So what this means is this. 5 will make a true statement. 6 will make a true statement. Could somebody give me another number that will make a true statement?
500.
500.
9.
9. Will 4 make a true statement?
No.
No, it won't. What could I change in that problem to make 4 be a true statement?
If you put a line under the greater than.
So greater than or equal to, right? So also, everything on the left-hand side of 4 won't make a true statement. 3 or 2 or 1 or 0 or negative 500. So today, one of the things we're going to be discussing is what numbers will make a true statement if we were to plug them into the original inequality. Okay? All right. So we just talked about this. Remember, we only reverse the inequality if we do what? Quickly turn to your shoulder partner. The two start the conversation. Go. When do we reverse it? Equality symbol. When?
When you're multiplying or dividing
By negative numbers, right? Okay. All right, here is number 1. I would like everybody to solve it. I shouldn't have to talk about anything with regards on the solving part of that. Solve and graph. All right, number 1. Obviously, we have to subtract 5 from both sides and then divide both sides by 2. Natalie, use the correct sentence frame.
I concluded that the solution is m is greater than 7.
That you concluded that the solution is m is greater than 7. Let's see if that's right. Divide both sides by 2, and that is correct. Very good. The graph is an open circle over 7. All the numbers greater than 7 are to the right of 7. Daniel, give me one number that will make a true statement here.
10.
Give me another number that will make a true statement.
40 billion.
40 billion. We can always count on Michael to give us huge numbers, right? That are way off the number line. But that's okay, because that does make a true statement. So what we're talking about here is all numbers that are greater than 7, like 8, like 9, like 10, or whatever Michael just gave us, 5 billion or whatever it was he said. Some huge, huge number, right? All right, everybody try. Number 2.
X is greater than or equal to negative 4.
Very good. Very good. We have to subtract 7 from both sides, then divide both sides by negative 3. We have to flip or reverse the inequality symbol in this one because we divided by a negative number. The solution is x is greater than or equal to negative 4. The graph, closed circle, because we actually are including negative 4 this time, arrow to the right. So what kind of numbers are we talking about here, Chris? Give me one.
Like 5.
Like 5. Somebody give me a negative number that will work.
Negative 100.
Negative 100? Whoa. Negative 100 is way out here somewhere, right?
100.
I want a negative number that will make a true statement here.
Negative 1.
Negative 1, yeah, because negative 1's like right there. So be careful when I ask you other questions like that. So we're talking about numbers that are greater than or equal to negative 4, like negative 4, like negative 3, like negative 2, and so on to the right on the number line. All right, let's go to number 3.
What did negative 4 also mean? This is great.
Yeah, I did say negative 4. What did you get?
I believe that the solution is m is less than 48.
Very good. We have to subtract 7 from both sides, and then we have to multiply both sides by a positive 3. Therefore, we do not flip the inequality symbol. M is less than 48. We're talking about numbers like what, Shane?
32.
32. We're talking about numbers like what, Shivnil?
Negative 100.
Negative 100. All right, there are lots of numbers. We're talking about numbers like any number that's to the left of 48 on the number line, so like 47, 46, 45, and so on. Okay, everybody solve and graph number 4. Frame, please.
I determine that the solution is w is greater than or equal to 50.
Okay, and so we have to add 4 to both sides and then multiply both sides by a negative 5. That's what makes us have to flip the inequality symbol. That is definitely our solution. So when you had your conversation, as I'm finishing up the graph here, when you had your conversation, Ella, about what numbers this represents, what did you guys talk about? What kind of numbers?
Like 50 and like 60.
Okay, yeah, so like 50 and above, right? 50, 51, 52, and so on. All right, so we're adding that to our conversation now. And it is now at number 5 that we're going to use the remotes much like we did yesterday. So before you start, I want you to listen very carefully because this part is just like yesterday. You're going to solve the inequality. The part that you will be putting in to your remote will be just the numeric part. But when we shoulder partner, we'll be partnering our solution and what numbers we think make a true statement in that solution. Everybody okay with that?
Yes.
Solve it first. I'll let you know when you can start inputting numbers into your remote. All right, we should have subtracted 10 from both sides, then divided both sides by negative 3, which means we have to flip the inequality symbol. I heard lots of, I concluded that the solution is y is less than or equal to negative 10. That is what you should have for the solution. And you should have talked about numbers like negative 10, negative 11, negative 12, negative 10, and lower. Okay? All right, let's go to number 6. Same exact kind of thing. Solve it first. I'll let you know when you can start inputting numbers into your remote. All right, we should have subtracted 8 from both sides. That means on the right-hand side of my inequality is negative 21. So I have C over 7 is less than or equal to 21. And here's sometimes, a lot of times, I put a lot of thought into the equations and inequalities that I give you because I'm very aware that some of you look at that and you think, oh, okay, negative 21 divided by 7 is negative 3. No. That's C over 7, which is C divided by 7. The inverse operation to division is multiplication. And we're not flipping the inequality symbol because we multiplied by a positive number. So the solution is C is less than or equal to negative 147. We're talking about all numbers negative 147 and lower, or to the left on the number line. All right, I don't think we need to try number 7. And the reason is because number 7 is much like the other ones that we did a little better on. Let me just ask this question, though, about number 7. Would we have to flip the inequality symbol?
Yes.
Yes, because we would have to divide both sides by -7 in that last step. Okay? But I do want you to do number 8. Michaela.
I concluded that the solution is n is less than 184.
Very good. We subtract 4 from both sides. For the few of you who did not get it right. That gives us n over -8 is greater than -23 because -9 minus 4 is -23. Some of you probably still need to add the opposite so you can see that. Then I need to multiply both sides by -8 because that is the inverse of dividing by -8. Since we multiplied both sides by a negative number, which is the multiplication property of inequalities, we need to flip the inequality symbol. So there is our solution. We're talking about numbers that are to the left of 184 on a number line. In other words, numbers that are less than 184. All right. We've got 2 problems left, and they're much like we've dealt with in the last couple of days. So now we're shifting it to a multiple choice situation. Much like those other problems, here's what you're doing. Listen carefully, please. Look up here. You need to solve this one and then solve this one, and you're trying to figure out which of them, A or B, or both of them, or neither of them, will have a solution of x is less than -3. Okay? Go ahead and go. I'll let you know when you can start inputting with your remote. Let's talk about number 9 here. In number 9, we on inequality A, we subtract 2 from both sides, which gives us -4x is greater than or equal to 12. We have to divide both sides by a -4, which means we have to flip the inequality symbol. That makes this solution x is less than or equal to -3. So that one works. For part B, we have to add 7 to both sides, which gives us x over +3 is less than or equal to -1. We already have division right there, so we have to multiply both sides by 3, and that gives us x is less than or equal to -3. They both have that as a solution, and that is what most of you got. The correct answer is C for that one. Okay? All right. Let's now go to the last problem for today. This one should only take a few seconds. Give me a few seconds to get this thing going. And you may start answering.